So one thing I want to remind everyone of is this: what I care about more than anything else is your actual learning. How much do you actually understand about the content? So whenever we have an assessment in class, if you do poorly on that assessment, then there will be opportunities for you to retry it and show me that you've learned it better. Now, when it comes to quizzes, right? Hey, I need you to pay attention to me. When it comes to quizzes, you will later take a test on that material, and if you do better on the test, I will let that test grade replace the quiz grade, right? But did we ever take another assessment on the review unit that we did? Did we ever do another assessment? How many assessments do you have on the review unit? 1 or 2 or 3?
Hey, on 9 and 10 I got a 3.
We'll address it later. How about you answer these questions first? How many review assessments did you have? Well, how many do you have in your hand? That's a review unit assessment. 1. There's only 1 assessment. I told y'all after that assessment, I had a redo so that you could retry, or reassessment, so you could retry that assessment if you learned from your mistakes. 0 students took advantage of that. 0. Right, I'm not saying everyone needed to. I'm saying if you do poorly, learn from your mistakes, come in and do a reassessment. Now, I have tutoring Monday, Wednesday, Friday. If you're struggling with content, now, and Peyton, this does address part of your issue last week. You came in on a Thursday morning. Monday, Wednesday, Friday morning is when I'm up here from 7:20 to 7:55. Tuesday, Thursday morning is when I am here after school from 3:15 to 4, as long as you let me know ahead of time. I'm here to help you become successful. So if you're struggling with something, come in and ask questions. Tutoring is not a bad thing. Tutoring is a, hey, I care about my grades and my understanding thing. Take advantage of it. There's 3 hours plus of tutoring every single week. Take advantage of it. It's free.
I did last year and it sucked, but it helped.
I wouldn't say it sucked. I would say that you got significantly better and stronger at mathematics when you finally started coming into tutoring.
Oh yeah, I got a lot better, but it still sucks. I didn't understand that.
But it sucked that you didn't understand it before, but you understood it after, and that's why you scored better. Right? Like,
I'm making a B in this class now. Or a C, what?
I think you have a B right now. Right? And it's because of the hard work you put in last year to get better. What are you going to say, Kelsey?
I used to have a B in this class right now, so I didn't do some of the stuff that I was supposed to.
Well, and that can hurt you too. But like that means that you would have a higher grade. So these are things to be aware of. And so take advantage of these chances to do reassessments. Now, this is the only time I'm going to do this all year. However, on the 9 weeks exam, if you do better on the 9, so I have it split up into the review unit and to the equations unit. If you do better on the review unit portion of the assessment than you did on the original review assessment, I will let you take the higher grade. Similarly, with the equations unit section, if you do better on that than you did on the original quiz that we had Friday, then I will let the higher grade stand. So you need to take advantage of asking all the questions to fix any of your misunderstandings so you are ready for that review, or for that 9 weeks exam tomorrow. We clear on that? That makes sense? Know what we need to do? Ask all the questions. Mistakes are great and they're learning opportunities, especially if you take the opportunity to learn from them and ask those questions. So here's today's agenda. We're going to go over the review assessment first, and then we're going to go over the equations understanding check. And then honestly, y'all can do your enrichment at that point probably, because we'll probably use up all our time. However, what I would recommend is that if you want to pay attention and want to go over the equations practice, I'll give you that option during your enrichment so that you have more time to get ready for your 9 weeks exam tomorrow. But it's your choice. I'm not going to force that on you. So I do want to remind you, this is the rubric that I use for every single assessment. This is the rubric I'll be using tomorrow on the 9 weeks exam. Remember, 4 through 6 is whenever your solution or response is valid. -1 through 3 is anytime you at least make a part of a mistake. So what is the difference? Why is there a 4 to 6 and why is there a -1 to 3 if it's correct or incorrect? What's that all about? What's the difference between a 4, 5, or a 6?
How well you justify.
How well you justify it. And it's not as a punishment. It's not just, hey, you got it right, but I don't want to give you the points. It's so that you know, hey, maybe I got the solution right, but I have a major error in my understanding. Or I just didn't justify it at all. Well, you got to fix that if you don't justify it. If you got a major error in your understanding, that might hurt you later. So I'm trying to give you a heads up. Hey, you have a major misunderstanding here, and we need to talk about it. 5 and 6, you're still doing pretty well. And also here, -1 to 3, as long as you show some work, some justification, you're looking at that 1, 2, or 3, that's good for you to get some credit rather than none. Take advantage of this rubric to understand what questions you should ask. All that being said, what questions do you have from numbers 1 through 5 from the review assessment? So just starting with 1 through 5, what questions do you have on the review assessment? We got all those perfectly right?
No, wait.
That's why I asked you to get the review assessment out
I don't
earlier.
know what it is though. I don't have that.
You do. I give it back to everyone at the same time. So remember, I asked you all to put the assessments as the last thing in here, so you can just flip to it. There it is.
My biggest problem is I just keep screwing up their cursor and explicit. That's my only problem.
Well, then let's talk about this explicit.
That's literally my only problem is you keep putting either recursive or explicit, and I keep screwing either one of them up.
Yes, I gave it back to you earlier. I gave it back to you on Friday, I think, actually. I gave it back to you on Friday. I don't know. I'm going to get started, though. Look for it while we're starting, okay? Did you look in this front section up here? Yeah, I don't know. So look for it. Hopefully you can find it soon. Okay. One thing, huh? One thing I want to quickly talk about. Yes, ma'am. No, we're going to ask questions about. Your questions are more important than what I want to talk about.
Good question. I mean, yeah, this is half of the every dies. How do you multiply them? Why do you multiply?
Well, half is a fraction, right? When you have a fraction of something, what mathematical operation is that? Look up there.
Wait, what was the
A
question?
fraction of. Up there it actually has
I
a,
see it, I see it.
it's under multiplication, right?
Yes.
So remember, it is half of, so you are multiplying by 1/2. Now I will point out that is equivalent. You'll notice I used the 3 lines instead of 2, meaning that they are effectively the same, not equal, but effectively the same. Multiplying by 1/2 is the same as dividing by 2. Notice how you're multiplying by 1, and then what does this fraction bar mean? Dividing by, that is division by 2. But that multiplication by 1/2, 1 should very quickly tell you, is it linear or exponential? Because you're repeatedly, remember, an exponential function has a multiplicative rate of change, a common ratio. That's why I would say, hey, I would recognize it as multiplication first. Because you can quickly, and I will point this out, you need, whenever you say exponential or linear, you need to say, hey, it's exponential because it has a multiplicative rate of change, right? That common ratio is 1/2. Whenever you say linear exponential, it should not be because, oh, it has a line or it has a curve. It should be because it has a certain rate of change. And we should recognize that it is repeatedly multiplying by 1/2, right? 0 months in, how much algae was in that harbor? How many square feet of algae?
150,000.
Beginning of fall, there was 150,000. Then half of the algae dies per month, so we're multiplying by 1/2. right? Make sense? Now, we'll point out in here, I think everyone correctly understood or remember that when we scale our axes, we have to add and subtract. You cannot multiply, right? So I would have scaled by 20,000s. And I'll just put in the K because of time, trying to save a little bit of time, but always write the number out all the way. But notice how when I'm scaling, I'm not just putting the numbers that are there. I'm scaling it by adding the same amount every time. When you scale axes, you should scale it by an additive rate of change. But that's always a scale. That's not based on what type of function it is. One thing I do want you to consider on the 9 weeks test that I did not hold you accountable to when we took this is 20,000, 40,000, 60,000, 80,000 what? Right? Algae in square feet. You should label your axes. 0, 1, 2, 3, what? Months. You should always label your axes. And Peyton, we're about to get to the equation, but I will point out that a lot of students miss discrete versus continuous here. Any of us do that? Huh? Well, look at it. So you got a 2. Remember, 4 is saying it's correct. 5 and 6 is correct with the right justification. So you got it wrong. Yeah. So that's where you need to ask questions. That's what the rubric is all about, though. So first off, if I'm talking about algae in a harbor and it's going from 150,000 and dropping to 75,000, is that going to constantly be dying off, or is it just going to jump down to that next value?
Well, constant.
Right. If something is constant, it is continuous. Because continuous, remember, means that it's going between the points. Not that it continues forever, but that you continue between the points. Because these algae are constantly dying off. Now, another detail that you may want to write down. So I pointed out, hey, if it's exponential, you need to talk about a multiplicative rate of change. A good thing to note is if it's discrete, that means you are counting something usually. If it is continuous, that usually means that you are measuring something. Are you going to count the square feet of algae, or are you going to measure that? You've got to measure that square feet of algae. So it's got to be continuous. And so what I would always think about is and I would write this note down, if I'm looking at discrete, I need to be counting something. If I'm measuring something, it needs to be continuous. Right? Counting discrete, measuring continuous. All right. Up through this point in the year, there are only 3 explicit equations we've learned. Now, I don't want you to just memorize these 3, but it does significantly help to know these. These first 2 equations are for what type of function? So if it has a slope, though, what type of function is that? Linear or exponential? Linear. First off, does it have an exponent? Nope. And notice how we're multiplying the slope times the variable, because what is multiplication? Repeated what? Addition, right? Linear functions have an additive rate of change. This is multiplicative. So what explicit equation am I dealing with? The exponential, which is y equals a times b to the x. Now, I don't want you to just blindly follow that, but I do want you to consider y. That's my output, my algae in the harbor. How much algae starts in this harbor?
150,000.
So A, my Y-intercept, is 150,000. Every month, what's happening to that 150,000?
Decreasing.
It's not, when you say decreasing, we usually mean subtracting. And it is going down, but what are we really doing to it? Multiplying by half. So it is decreasing, but we want to recognize what type of rate of change is that. We're multiplying by a half, right? Starting at 150,000, we're multiplying by 1/2 every time. But then how do I show that I'm repeatedly multiplying by 1/2? I need an exponent. And because it can change, that exponent needs to be an x. Peyton, does that make sense?
Why is it mine like?
What else what do you have?
Isn't that the same thing?
Nope, because you're multiplying by n.
You're multiplying by x?
No, I'm not.
Oh. Okay.
What is that x?
An
An exponent, right?
yeah, sure.
Not yeah, sure, or you need to notice, because it's important. It's what we just talked about, right? Multiplication is repeated addition. That's a linear function. An exponent means I'm repeatedly multiplying. What are we doing here? Repeatedly multiplying, right?
Okay.
Do you see that difference?
Yeah.
But like, that's not me like trying to pick on you. That's an important distinction that will mess you up for the rest of the year if you don't understand that now. So like, remember, this is your assessment. I would take as many notes as you need to make sure you don't make that mistake again. Right? We're repeatedly multiplying by 1/2, so I have an exponent. Any questions before we move forward? Peyton's just already nodding off. It's okay, I know I bored him. Kelsey has the same issue.
Well, I wasn't gonna say it, but at least you know.
Excuse me?
So, do you remember we took away years, we made this days? Because that made your life much easier. Because day 1, how many meals were there? There were 5 meals given. Right? Day 2? 8. 3.
11.
Day 4? And so we need to recognize that before we even graph this, we should know what type of function this is. What is it? Is it linear or is it exponential? Why?
There's a rate of change.
What type of rate of change? All of them have a rate of change.
Add.
Additive? Does a linear function have an additive rate of change? Notice how we're multiplying with linear, so we're repeatedly adding. Okay? And so notice, whether you're talking about linear or whether you're talking about exponential, what do you need to indicate in order to get full credit? The type of what? There will be problems very similar to these on your 9 weeks exam. You need to make sure that you indicate the type of rate of change if you want to get full credit. Is a relationship discrete or continuous? Should I leave it as isolated points or connect those points? What's the detail we talked about with discrete versus continuous earlier today?
If it's continuous,
Oh,
connect the points. If it's discrete, then leave it alone.
That's not what we talked about earlier today. It's what we talked about when we learned. Say again. Counting versus measuring.
We're counting.
We're counting, so it's going to be, there you go. That's all you have to identify. We're going to count those meals, so it's going to be discrete. But also, is this gentleman going to do anything between day 1 and day 2? No, day 1 he's giving out 5 meals, day 2 he's giving out 8. That's it. Now, when it comes to writing the explicit equation, notice I am skipping the explain what each number and variable means, but I'm talking through that, I'm just not writing it out. Should I use the slope-intercept or the point-slope equation here? Well, to use slope-intercept, what do we have to have?
Slope and an intercept.
Do we know what the slope is? What is a slope?
Oh, rising.
It is rise over run. There's something else that we need to remember with it. It's the additive rate of change, right? Do we know what the additive rate of change is? Plus 3, right? Notice it is plus 3 over plus 1. So remember how you just said it's rise divided by run. The y value is your rise, the x value is your run. So the slope is 3. I'm repeatedly adding 3. That's an additive rate of change. Do I know the y-intercept?
No. Wait, yes, yes.
The y-intercept is the output when the input is 0.
I mean, you could just do minus 3.
Could I go backwards to the y-intercept? Yes. If you wanted to do that, you could very easily say, hey, my slope is 3 times x plus my y-intercept of 2. Totally valid. Now, what is given, though, could I do slope-intercept?
Wait. The 3 is from that side or the other?
What is 3? That's my
Oh. That's just,
slope.
okay.
And remember, the slope is my additive rate of change. Right? We're multiplying, so that's repeated addition. But as what's given, do I have a y-intercept up there?
No.
So, I have a point. So can I use point slope?
Yeah.
You got to know these different equations. Y equals, my slope is 3, times x minus x1. What is the x value of that point?
Wait. 1. I don't know.
The x value?
5?
Remember,
1.
x, y,
1.
plus y1, which is?
5.
The y value of the point is 5.
Wait.
Now, that's just knowing the equations and plugging in what you know. There is another way to write it, though, which is very similar. Remember how y is my meals given? How many meals do we start with?
5.
5. What am I repeatedly doing to that 5?
Adding 3.
So I'm adding 3, but then mathematically, how do we show repeated addition? Multiplication. So I'm going to multiply by my variable because it's changing, but I started on the first day, so I need to do x minus 1.
That's what I forgot. I forgot the minus 1.
Isn't that equation the same as this one right here? It's 3 times x minus 1,
Mr.
and it's a plus 5.
You gave me a 2 because I didn't have the minus 1.
I can guarantee you that is not why I gave you a 2. You said f of 1, that's the other big issue. F of x. See, as even said, you mixed your recursive and your explicit. F of 1 does equal 5, but then if you want to write the explicit equation, you need f of x equals 5 plus 3 times x minus 1. So you had 2 different issues there. Does that make sense, though, and how you can fix that? Remember, mistakes are okay, guys, but that's why you need to investigate them and ask those questions. You could have come to tutoring weeks ago and asked those questions to fix your misunderstandings, and then done a reassessment. Okay, numbers 11 and 12. Anyone want to know what the most common mistake I saw in number 11 was?
I don't know.
I saw a lot of students do this. Meaning that the starting value was what? If they made this table, what did they say their y-intercept was?
30.
And then their rate of change was what? They're adding 50, right? But repeated addition is what mathematical operation? Right. So what am I actually repeatedly adding here?
30.
That's my additive rate of change. Identify your rate of change first. So if that's my rate of change, what does this 50 have to be? My starting value, right? And then what am I repeatedly adding? So notice how I said m equals 30, that's the additive rate of change. and I'm explaining that this is my y-intercept. Do you think that's enough credit to, or enough justification there to get full credit for a 6?
First I put 30 for the 0, but now started adding 30.
You see how that was, how to fix that though? Does that process make sense of, hey, I'm multiplying, so it's repeated addition by 30? Y-intercept is 50. I will also point this out though, there's an alternate way to do this. Can I do f of 0? Meaning I'm plugging 0 in for what? The x? Can I do that? This is an alternate way to do it, but you could have done 30 times 0. My x is 0. What's 30 times 0? 0 plus 50? Right? F of 1. That'd be 30 times 1 plus 50. What's 30 times 1? 30 plus 50? F of 2. 30 times 2? 60. 60 plus 50? So is this a valid alternate way to get the correct points and to get the correct graph? I would accept that as full credit as well. Now, I do think that that method up there is an easier method, but this is totally valid. And it'll always work. So you pick which is easier for you. I don't care. I'm here to give you options. Right? The same way g of 0 would equal 2 times 4 to the 0. G of 1 would equal 2 times 4 to the 1. G of 2 would equal 2 times 4 to the 2nd, etc. Do we see how we can use function notation to plug things in for our variable? Any questions about that? Now, Emery, I do want to ask you, looking at g of x, what is my rate of change? Not sure? Okay, I'm going to call on someone else and I want you to see if you can figure out why they think this is the correct answer. Shelby, what do you think the rate of change is?
4.
What about that 4 though?
4 raised to the x.
Okay, but what are we mathematically doing with that 4? Like what are we, because remember, rate of change is how it's changing.
Yeah.
What are we doing with that 4? How is that changing?
You're multiplying.
Okay, so it's a multiplicative rate of change by 4, okay? So Henry, why do you think she said that that 4 to the x is a multiplicative rate of change, that we're multiplying by 4 every time? What is here?
I need Emery Parker for checkout, please.
She is on her way. Before you go, why do you think she said 4 to the x would tell us to repeatedly multiply?
So it's being multiplied.
Not just that. Say again.
3 is being multiplied by x.
It's not being multiplied by x. X is a what?
Exponent.
An exponent. And guys, what is an exponent? Repeated multiplication. Remember, multiplication is repeated addition. An exponent is repeated multiplication. So I know I'm multiplying by 4. So my common ratio is 4. So what does that 2 have to be? Say again. Starting value. That's my y-intercept. So when I plug in at 0, 4 to the 0 is 1. 2 times 1 is 2. There's my y-intercept. Notice you can plug it in, or you can just identify your y-intercept. And what are we doing to that 2? Have a good rest of your day. So 8, 32, 128. We good with those ideas? Okay. But once again, when scaling, can I just put these numbers on the graph? Because if you do, it will mess it up. If you just do 2, 8, 32, 128, which that goes to be. What does that look like to you? A line, right? But it very clearly is a multiplicative rate of change, so it should be exponential. That's why you have to scale correctly and pay attention to those details. Any questions before we move on? All right. I'm not gonna go over all these. 13 through 20, which ones do you have questions about? Either because you did not know how to justify it or you got it wrong.
13.
13. What do we mean by domain? Peyton, do you remember what we mean by domain?
No,
We gotta know this. It's gonna be on your 9 weeks exam.
I really can't remember. I know it's domain and range. Domain is every set of inputs.
So which variable is inputs,
X.
right?
It's every set of inputs. Like the range is every set of outputs.
Right.
Everything on the y-axis.
So when I look at the domain, every x value, what is the lowest x value that we have graphed?
What were you on?
1. It's 1. What?
The x value of 1 is the lowest x value?
What?
We're looking at x values.
0.
Are you looking at this over here?
Oh, yes.
Is that an x value or a y value?
Oh.
See how it's touching the y-axis? That's a y value. I drew a line here at x equals 1 because you said 1 was the lowest x value. Is that the lowest x value that we have? What's the lowest x value?
0.
See how that's the first x that I have? At 0? What?
Oh, okay.
You go with that now?
Yeah.
So what's the highest x value that I have?
22.
Are you looking again at the y, Kelsey?
Oh my gosh.
Remember, x is from left to right.
X.
So. Oh,
5, 10, 15, 20.
it's 10. It's 10. 10 up. 10 up.
Chelsea,
That's the highest.
listen, okay? I've got eye problems, okay? I can't see very well.
Hold on.
I'm just-
Listen to what she's saying though. She's saying it's the highest. But what are we asking? We're not asking for the vertically highest. We're asking for the horizontally highest. What is the last x value that is here?
It's every set on the x value, not...
This is so confusing.
Kelsey,
Yes.
which axis is your x-axis? The horizontal one, right?
Yes.
So I am going from left to right. I'm not going up. I'm going from left to right. What is the highest x value?
Oh, it's 30? Wait, no.
5, 10, 15, 20, 1, 22.
I didn't know where the lines were going by. Sorry.
Get it.
5, 10, so it's going by ones.
Oh, sorry. Okay.
It's like watching a child take the first steps.
Does that make sense now?
Yeah.
You've got to remember the x-axis is horizontal. So if we're talking about domain, we're talking about horizontal values there.
Hey, it's 2020, you cannot judge.
Is it a safe assumption we need to talk about the range on number 16 as well then?
No. I know that one.
Okay.
Wait. It says why. How much? Wait.
If domain is every x value, range is every what?
Wait, which number is
Y
range?
value. Kelsey,
Hold on, I don't know which
come
one.
on. You got a higher grade in this class than I do.
Range. Where's range? What question are you asking?
16. I already said that one.
16. Oh, yeah, I got that one wrong too.
But look, if domain is every x value, the inputs, range is every y value, the outputs. What is the, so when we talk about y, we're looking vertically.
Yes.
What is the lowest vertical value?
1.
What's the highest?
10.
There you go.
What? I'm so wrong. I know that now, but I didn't.
She said 30.
But you had to struggle through the 0 to 22 and get the domain, and now you're like, oh, the range totally makes sense.
Oh, okay.
What other questions from 13 through 20 should we ask questions about? Yes, ma'am.
15.
15.
That's it for me. That's all.
What is a relative maximum?
When it stops decreasing, it starts.
A relative maximum?
Oh, wait. I
Shelby.
get this
Maximum.
confused. When it stops.
A
Increase it
relative
starts to-
maximum.
Yeah, when it stops increasing.
Yeah.
So, And it's a little bit more than just that, but that's the colloquial or personal definitions we'd be okay with. But anytime the function stops increasing and starts decreasing, you're going to get a max, right? It's like the top of a roller coaster. You're going to stop going up, you're going to start going down. So we always read from left to right, so I'm increasing, constant, increasing, and then decreasing.
19.
Yeah.
What the hell? Why did I put that? I'm so dumb. I put 9.
I mean, we weren't gonna.
So there
say
was
anything.
no minimum, because a minimum is when it stops decreasing and starts to increase. That never did happen.
How am I supposed to explain that?
For
It
15?
says why.
15 or 14?
14.
Well, couldn't you say a relative minimum occurs when the function stops decreasing and starts increasing?
Just put when the graph stops decreasing and starts increasing.
Okay.
You don't have to put.
See how I basically defined what a relative min is or a relative max, and I use that to drive my answer.
Yeah.
That's enough justification for me.
Okay.
That's all I'm looking for.
Okay, I'm gonna ace this.
Say again.
That's what I put.
Yeah. And so again, I told you all at the beginning of class, if you do better on the 9 weeks exam than you did on the review assessment, I'll reward that, right?
Wait, is this the review?
So don't be dumb on the 9.
That's the review assessment. Yes, ma'am. All right, we ready to look at the equation stuff? Devin,
That's
I know you didn't get a chance to take this assessment. Do you have any questions before we move off of it? Okay. So let's look at the equations that I just gave back at the beginning of class.
You didn't give me anything.
I did not give y'all's back. Just kidding. I will give it back now.
Oh, so what are you talking about?
I'm cuckoo for Cocoa Puffs. What can I say?
I don't see any Cocoa Puffs.
It means you're crazy.
Yeah, I know what it means.
I did give y'all's back.
What is it?
I gave it back at the very beginning of class.
No, you didn't.
I
You
did.
gave us,
This is the only thing I have.
you didn't give us anything.
Yeah, I did.
But you
I'm
can't.
confused. I
No,
only
you
have
didn't.
3 pieces of paper on my desk.
Look in your notebook, because why else
I didn't even put anything on it.
with Chris's, yeah, where it says equations and inequalities understanding check? Come on now.
I get it right here.
Yeah, because I did pass it back. See, I knew I wasn't crazy.
Cool.
I'm still cuckoo for Cocoa Puffs, but
Wait, what?
in a different way.
Okay,
Okay, Cocoa Puffs are
I got a
delicious.
lot of, I got a lot of questions on this.
Okay?
Because I didn't
He just gave it to us, Peyton.
I literally gave it back at the
It
beginning of
doesn't
class.
mean anything.
It should.
Oh.
It's sad that you already lost it.
I don't think that you gave mine back because I don't lose.
Peyton, I did.
Often.
1, I don't believe that. 2, I gave it back.
Hey, I kept this over the weekend, man. That's the only 2 sheets of paper I have on desk. And I didn't go through. This would be 3, 4, 5. That's the last thing I got.
I literally just gave it back.
I know it's not that because I organized about what you give me, so it would be right here. You did not give me mine.
I did, dude. I had to have.
I believe you're crazy. So.
I'm not. I gave it back. What did you do with it?
I didn't do anything with it.
No one believes you. Did you put it in your backpack?
It disappeared.
Oh my gosh!
No, I definitely did not.
I definitely did not put it in my backpack.
You didn't give it to me, Mr. Kidding.
That's right. I'm the crazy one. Okay. Any questions about number 1 here?
Wait, why? Yes. Actually.
Why what?
Yes. Why do I have a 3.5 on this?
I mean, did you put C?
I put
I
C.
put D.
I put C.
Well, D was wrong.
Is C correct?
C is correct.
Okay. Hold on.
So why is it C though? How do we know it's C?
Because
Because the first thing you do to the x is you triple it.
Right.
Constant.
The first thing that happened was tripling the amount. And you could very quickly write a short sentence about that. The first thing being done to the variable is tripling. Now, Peyton, the reason why I think you put D and what messed you up was you saw this idea that each student had 2 friends to come sit with them, right? But if I have 1 friend, 1 friend, 1, 1, and I add 2, Notice originally I had 4, now I have 12. You see how it triples?
How do you spell triple?
It's in the sorting,
Oh, okay.
right? So I think that's why you put that +3, Peyton. Is that a safe assumption?
You know, Mr. Kenny, you make my head hurt sometimes.
Good. So when our head hurts is when we're thinking and learning, and that's the good thing.
Not when you fall asleep in the fourth period.
Divided by 5.
Yeah, we were tripling, and then it was being divided into 5 groups. Then we were adding 3. Something that an earlier student did is, so David Gay said, hey, I have these 3 numbers, or these 3 parts of the story. This happened first. This happened second. This happened third. I'm good with that, right? That's identifying each of the things that happened.
If I would have put that all the way up.
Yeah, and full credit, a 6 out of 6. I even told you all that before the assessment started.
No. Sometimes I just don't listen.
I know. Mr. Kitty, why don't I understand this? Did you listen when I taught it? No.
Hey, Jalen didn't listen to crap last year, and he somehow made it out.
Jalen's mind is, and I know you don't believe it, brilliant. His ability to think, not what he knows, but his ability to think is really strong.
He thought the capital of China was
That's
Tokyo.
That's something that you know. That's not your ability to think. You keep focusing on facts. Honestly, facts don't mean that much anymore. You can Google any fact. His ability to think through problems was strong. That's what you need to focus on. 2 through 4, any of these that we had questions
I
about?
got
Ability to
every single
retain
one of them
anything
wrong.
was crap.
You got everyone wrong?
I got every single one of them.
That's because you didn't answer 3 or 4.
Because I didn't have to go back to because I couldn't understand.
It's okay, look at the back.
Okay, you made it way more complicated than you had to, Kelsey.
My students did it.
Okay, well, I know number 1 because I know
I
it's
just
not
guessed on that
property of
Let's do
equality
it.
because you're not doing it
I get
together.
it.
So.
Please hear what Kelsey said, because this is important that we need to pay attention to. This first step here can't be a property of equality because it's not being done to both sides, right?
Okay.
It's only being done to this one side. What allows me to do 3 times 2x and 3 times -1?
Distributing.
That's just distribution,
Distributation.
right? And all you would honestly have to do is say, hey, 3 is being distributed to both the 2x and the -1.
Wait.
That's it.
Huh?
All you would have to say to justify it is that 3 is being distributed to the 2x and to the -1. That's all you had to say.
I didn't notice that.
My
Where?
teeth hurt.
What do you mean where?
Oh, I see now. Okay, no.
Okay? Notice the next step was just simplifying. That was it.
Wait, this is just one problem?
Yes, that's why it's blocked together.
Okay, that's just like common sense.
I did not know that. Okay,
Then what's the next thing happening?
it's
+3.
Oh, I did not understand that part.
Well, we're adding 3 on the left-hand side of the equal sign, and we're adding 3 on the right-hand side, right?
Oh, because it's one equation. Oh my god, I'm so slow.
So what would this be?
Oh my gosh, that would be, you
Property of
cancel
equality.
them out. You cancel
Well, it
them
does
out.
cancel out. That's why -3 plus 3 is 0, and we're left with 6x. But what property is that? You see how we're adding 3 on both sides?
Oh my gosh, yes.
So the addition property of equality. Why? We're adding 3 to both sides of the equation.
Oh my gosh.
Done.
You know it's bad when she gets me confused on my path.
Does that make sense?
Yeah.
We good? So then what's the last step here? Number 4.
Oh my gosh. You should have made it clear that this was just one problem.
Peyton, did you know that?
Common
Yes.
sense, yes.
Shelby, did you know that?
And
Yes.
Yes. I don't remember Devin. Did you know that when you were doing this one? You did not? Okay, so Devin didn't. Emery did. The most students all day realized that. There were 3 students, maybe 4, that got confused on that.
And how
Whoops.
are you gonna do divided by x divided by
Yeah,
x?
that's what I'm so confused.
But there's
That's
no
what I'm
x
like-
because there's no problem. Like, what? Why?
Yeah, that's
What?
what I looked
There's
at
no
it.
division by x.
I was like,
We're dividing by 6.
Oh my lord.
Yeah.
Why am I
6
crying?
divided by 6
I'm
is
saying-
1.
What I'm saying is, how's that gonna happen if there's
that's
no
the vision
equation?
property of equality.
Thank you.
That's got to be an equation. That's gotta be a whole equation.
Oh,
Otherwise,
oh,
we
yeah.
get the 6.
The answer's right in front. Oh my god, I'm so
Yeah, the answer was there.
There's a 6. Where are you gonna get the 6 from if there's no equation?
I don't know, I thought it was just randomness and I didn't understand.
Kelsey.
Hey,
Instead
Kelsey,
of rushing
read
through,
directions.
take
The
10
following equation has been solved for x. Match the appropriate property to each step in the justification table.
You should put, this is just one problem.
You should read directions.
Kelsey, if you'd stop rushing through it and just take like
Well,
all
you
up.
only gave us like 40 minutes.
Listen, I know.
Excuse
I know,
me?
You're just way too good for this, but if you take like 5 seconds.
I gave y'all 25 minutes for 6 questions.
This is 6?
Because y'all didn't have to do number 7. And 3 of them were just writing the justification.
Yeah, I flew to the first page, Kelsey.
Excuse me, what?
Yeah, you heard her.
No, I didn't hear it. What did you say?
Okay. Number 5. I do want to let you know and remind
Flip to
you.
the back page.
Hey, when we solve the equation, what are we trying to find?
The answer.
But what is the answer?
Try to
Don't just say
summarize
the
this.
solution, which is, what is a solution?
Something that makes something true.
The value that makes the, not something,
Equation?
the equation
True.
true, or inequality, but we've only studied equations so far. So I had some students do this. So did they find the solution, negative 25? They plugged in negative 25. Did it make the equation true? Negative 30, does it equal negative 30? Yeah.
Yes.
So they found the value that makes the equation true. Did they find the solution? Yes. They got the answer, A. However, I will say I only let that be a 5 out of 6. Because if you do not have multiple choice, then it's kind of hard to be able to answer the question. Now, they did show me that they understand what a solution is by doing that, though. So they got most of the credit. Right? But realistically, to solve, what do we need to use to solve an equation? Inverses and the properties. Right? Inverses and properties of equality. So read the equation. What's the first thing happening to that n, that variable? It's being multiplied by 3. What's happening next? Plus 15. What's happening after that?
Divided by 2.
Now we need to just remember the last thing that's being done is the first thing that I need to undo. What's the inverse of division by 2? Multiplication by 2. It's still the same number, we just need to recognize that the inverse of division is multiplication. Devin, what is 2 divided by 2? It's how much? Not 0. What do I need to multiply by 3 to get 3? 1, right? 4 divided by 4? Anything divided by itself is going to be 1. 2 divided by 2 is 1. And then when I multiply 1 times anything, I just get that anything, right? What is 1 times 5? 5? 1 times 17? Right? 1 times 3n plus 15 is going to be 3n plus 15. What's negative 30 times 2?
You okay?
No. Negative 30 times 2.
Are you asking anyone?
Anyone?
Negative what times what?
Negative 60. Thank you. Now 3 times n.
It's not even math. Y'all just make my head hurt. That's what it is.
3. Now it's 3 times n, then plus 15. So what's the thing I need to undo now?
Minus plus 15, so you do
Minus 15.
Right? That's the last thing being done, so it's the first thing I undo. Now notice Devin, here, what is 15 minus 15? not 1. That's where we get the 0. Multiplicative inverses give us 1. Additive inverses give us
You
0.
gotta do that.
And then 3n plus 0 is just
You gonna
3n.
correct me in Spanish now?
Does that make sense?
Mr. Candy, she's correcting me in
Hold on.
Spanish.
Shelby, what is negative 60 minus 15?
Well, I have learned that it's negative 25.
How much?
No, Shelby, that's incorrect.
I mean 70.
Negative 75.
Your 7's good.
Gotcha. But what's happening between the 3 and the n? They're being multiplied. So what's the inverse of multiplication? Division. Now again, Devin, what is 3 divided by 3? That's where the 1 comes up, right? 15 minus 15 is the 0. And 1 times n is n. Negative 75 divided by 3 is... We're all good with that now.
Yes, we're good with that.
Any questions?
No.
Okay, number 7, we definitely need to get through this. I would recommend that we get through number 6, and then we can stop there if that's where you want to stop.
Can we just stop here?
We need to get through number 7 first.
To the...
I got that one.
So again, you can plug in the different answer choices, but we want to try to use our properties.
Well,
And our
you got
inverses.
that one.
I didn't because I plugged in each time.
So you can do that, it's just not going to be the easiest. What is the first property that I should use here?
You should do
Really?
plus 10. No,
You-
no.
So I will point out, can you add 10?
What side are you supposed to start on?
It doesn't matter. Can we add 10?
I'm just
I mean, what's negative 10 plus 10?
0.
And I did it to the other side, didn't I? But notice I can't add it directly to the 6 yet because these are being multiplied, so I got to do the multiplication first. So what I would have probably done is I'm going to simplify and distribute first.
Oh, 2x plus, plus 8.
Kelsey,
6, 7, 8. Oh, wait, no, it's multiply.
Kelsey,
It's 12.
take a second to get your
Slow
answer
down.
together.
I want to
before
point
you
out
do
how
something.
funny it is hearing Peyton of all people this year
Telling you.
saying it.
The only reason I'm saying it is because I'm not talking today because I fell asleep in 4th period, so I'm kind of tired.
Okay?
It's like,
So,
she's
but let's
saying
look
this
up
and she's
here.
like,
Now-
wait, no, it's supposed, wait, wait,
So,
dude, stop.
can I now add 10 to cancel out the minus 10?
Yeah.
Yeah. It's negative 10 plus 10?
0.
12 plus 10?
282.
Now, notice how we had to cancel out the number on one side, so I probably need to cancel out the variable on the other. I don't want 2x plus 12. What would I do to get rid of that 2x? Now, if I divide by 2, 2 divided by 2 is 1, but I don't want a 1x. I want no x on the right-hand side.
Times 0.
No, because that's going to, remember, whatever you do to one side, you have to do to the other, so you multiply everything by 0.
Oh,
We need this to become a 0. So I have to use the additive inverse. Currently it's positive, so I need to
negative.
subtract. What is 2x minus 2x? It's 0, right? Does that make a good 0 to cancel it out?
Yeah. And then 3 minus 2 is 1, and 1x is x. Oh my gosh.
0 plus 22 is 22.
Wow.
Are you clapping for yourself?
Does that make
Yes.
sense?
I'm excited.
Now I do want to point out, Kelsey did ask earlier, what side do we start on? It honestly doesn't matter. Let's say I subtracted 3x first.
How are you supposed to know which one would be the easiest way to do it?
You don't.
You guess.
Sometimes you play around with it.
Oh my gosh.
But it's not really much harder. What is 3x minus 3x?
0.
So 0 minus 10 is negative 10. 2x minus 3x is negative x. Whoops, plus 12. Well, I only have variables on the right-hand side, so I want to cancel out the numbers on the right-hand side, the constants. 12 minus 12 is 0. Negative 22 is equal to negative x. So it only takes one extra step.
Oh my gosh. Wow.
Personally, I'm never going to make a negative if I don't have to. So that's why I would have done it this way, so I subtracted 2x and get a positive.
Yeah.
Okay?
Alright.
Oh wait, go erase it again. Let me erase this. Wait. Never mind.
You good? Alright.